Right, number one, the rate at which rainwater flows into a drain pipe is modeled by the function R, where that R is that formula, cubic feet per hour, T is measured in hours, and T is between 0 and 8. The pipe is partially blocked, allowing water to drain out the other end of the pipe at a rate modeled by D of T equals 0.04 T cubed plus 0.4 T squared plus 0.96 T cubic feet per hour for 0 to 8. There are 30 cubic feet of water in the pipe at time T equals 0. So already I can see this is going to be an accumulation problem, and we have things coming in and we have things going out. So we will need to keep that in mind as we're doing this problem. Okay, part A says how many cubic feet of rainwater flow into the pipe during the 8-hour time interval from 0 to 8. So I want to know how many cubic feet. So if I'm looking at rates, which are cubic feet per hour, I know I'm going to be taking the integral. I just need to figure out which equation do I want to take the integral of. I want water flowing into the pipe, and it tells us that R is the water that's flowing into the pipe. So all I need to do on this one is simply do the integral from 0 to 8 of R of T dt, and then I get to use Math 9 to do this. It's going to be 76.570, and it's going to be cubic feet. That was worth 2 points. 1 point for the integral setup, 1 point for my answer. Okay, part B is the amount of water in the pipe increasing or decreasing at time T equals 3. Give a reason for your answer. Well, I pretty much need to know, is more coming in or more coming out, so I know if the water in the pipe is increasing or decreasing. So I need to find R of 3, the rate at which the water's coming in, and I need to find D of 3, the rate at which the water's coming out. And if I find R of 3, that equals 5.086. It's just plugging 3 into that formula. If I plug 3 into the D formula, I get 5.4. So I notice that the water coming in is less than the rate at which the water is coming out, which means more water is coming out. So the amount of water in the pipe is decreasing at T equals 3, and my reasoning was because R of 3 is less than D of 3. Okay, part C, at what time between 0 and 8 is the amount of water in the pipe a minimum? Justify your answer. Okay, minimum, that could either mean relative or absolute, but since they give you an interval, we know it's going to be an absolute. So I'm looking for an absolute minimum. Okay, so I am going to be looking at the derivatives. What I'm going to do, if I'm talking about the amount of water, I'm going to just start by, you don't necessarily have to do this, but I think it's going to be helpful. Let's write a formula for how much water we have. So the amount of water is going to be, we start with 30. The amount coming in is going to be the integral from 0 to T of 20 sine of T squared over 35 dt. And then we're going to subtract how much is coming out, which would be 0 to T of negative 0.04 T cubed plus 0.4 T squared plus 0.96 T dt. And I could have just written R of T, actually that would have been easier, and D of T, which that probably would have been a lot easier. Okay, so that's my formula for how much water's in the pipe. If I want the absolute minimum, I need to take the derivative of that. So the derivative of that would be the derivative of 30 is just nothing. The derivative of an integral is just the R minus the integral of the derivative is just the what's inside again. So R of T minus D of T. If I'm looking for minimum, I want critical numbers, so I'm going to set that equal to 0. So I'm going to take R of T minus D of T and set it equal to 0. To get that, I actually graphed R of T minus D of T, so I actually made that my y equals, and when I graphed that between 0 and 8, I got a picture that looked like that. So I would like to find where does that equal 0. So if you use the 0 feature on your calculator, you'll get T equals 3.271658. And then from here, I would like to find an absolute minimum, so I'm going to find the amount at 3.271658. I'm going to find the amount at 0, and I'm going to find the amount at 8. Okay, and to do that, now I have my formula, so all I need to do is plug things in. So if I plug 3.27658 in for my T, I will end up getting 27.965. If you plug 0 in, well, We just know at time 0 there's 30 cubic feet in there, so we're set with that. And then at 8, if we plug 8 into that formula, we'll get 48.544. So the question was, at what time is the water in the pipe a minimum? It doesn't say what is the minimum, at what time does that occur, and the minimum looks like it occurs at the t equals 3.272, so equals 3.272 if I round it to 3 places, hours. And it did not say to round to the nearest hour, so we're going to stick with that. Okay, part D. Whoop, I haven't been doing points on these. I'm going to go back to part A. I did points on A. I forgot to do parts on B. On B, if we considered R of 3 and D of 3, so we talked about those, we'd get a point, and then if we have the right answer with our reasoning, we get a point. Okay, this part was worth 3 points. If we considered R of t minus D of t equaling 0, we'd get a point. If we found the right answer, we'd get a point, and if we have this justification, we would also get 1 point. Part D, the pipe can hold 50 cubic feet of water before overflowing. For t greater than 8, water continues to flow into and out of the pipe at the given rates until the pipe begins to overflow. Write, but do not solve, an equation involving one or more integrals that gives the time, w, when the pipe will overflow. So I pretty much need to know when is the amount of water in my tank going to be 50 or above. So if we want an equation, so it didn't say an inequality, just an equation, I already had an equation for the amount, so I'm going to stick with that equation for an amount. I'm not going to put A equals though. My amount was, again, 30 plus 0 to t r of t minus, don't forget that dt on there, 0 to t d of t dt, and we want to know when that amount is going to equal 50, because that's when the tank would start to overflow. I'm also going to change one more thing about this problem. It said we want a time w, so instead of using a t up here, we're going to figure out what would that time have to be. Okay, so this is the equation setup. That's all they were looking for. We get 2 points, 1 point if you do have some integrals in your problem, and then 1 point if you actually have the correct equation.